Mark, welcome to the Leanpub launch video for Designing Deterministic Systems with Modern C++, host first development on Linux. I was wondering if you could take a moment to talk to us a little bit about yourself and about your book and what it's about and who it's for.
Sure. I grew up in a small town in northern Maine, up in Stephen King country. It was a mill town. I've been a tinkerer from a very young age. It- when people asked me back then in first, second grade what I wanted to be, I said an engineer or a scientist. And I built telephone systems with strings and cardboard all through the house. My mother was very patient about it. Legos were my favorite toy. Uh, I built the Starship Enterprise and stuff like that. I built a lot of different things. I started to get AI chemistry set and all that stuff. But really what I found I liked was electronics and computers as I got older and was able to access those things. I made a crystal radio for a science fair in sixth grade. Lost out to the kid with a fetal pig from the biology lab, but that's a thing. Uh, so, and yeah, I've tinkered on any number of things. I had a TRS-80 color computer. I spent my money on that instead of a stereo like my friends. Uh, and didn't learn how to program BASIC, and all that. And I just tinkered with all kinds of different stuff. I took a rotary telephone apart and hooked it up to a counting circuit to see how the dial worked,
Cool.
and stuff like that. And then just got more and more into software. I found that I really liked that. I think you could morph it into anything, easily, more easily than hardware. So, uh, yeah. So, it was odd. It was a mill town, very blue collar. So,
And
um,
did you study engineering in university or anything like that?
yep, yeah.
Okay.
I studied computer engineering at Syracuse University. Um, I kind of pioneered going out of state for school because before that, everybody went to pulp and paper school down at the University of Maine.
Mm-hmm.
I
Mm-hmm.
didn't want to do that. And quite a few people actually followed me out to SU in the coming years. So it was a good computer engineering program. I enjoyed it. Was able to get a job right out of there at GE in
Oh,
Syracuse.
cool. Okay.
So
Cool.
yeah, so
Yeah, that's great. And so just to talk a little bit about your book, so for all those of us who aren't engineers, what's an embedded system?
so an embedded system is you have a piece of hardware that has devices that you control. So microwave oven's an embedded system, where you're controlling the motor on the carousel and running the whatever the microwave device is called. I'm drawing a blank. Accepting input. Um, in my book, it's a small Internet of Things device for gathering weather data remotely from different sensors, temperature and
Yeah,
pressure and
it, it
humidity.
it's very cool. I always love to see books where you actually build something, where you build something in the book that works. And in here, it's something called the Weather Reporter device.
Yep.
So you just reminded me of a funny thing. I remember reading this. I don't know why this little thing struck me so much, but it was years ago. It was a BBC tech author who was writing an article about something, and he said he didn't dare tell his mom that her remote control was a computer. Um, because once he did, he knew she'd stop using it because she wasn't a computer person or anything like that. It
That
was
would
her.
be my mom too.
Yeah. That's a lot. Well, there's a lot of people, and there's actually a lot to think about there. But computers are actually embedded in things all around us, which means
Yep.
programming is basically kind of physically all around us and is
Yep.
determining how our things work and stuff like that. So, you right off the bat in your book description, you say it's about treating Linux as something, not treating Linux as something to port to late in development, but starting like with the Linux host. And I was wondering if you could talk a little bit about where that opinion kind of developed, because I don't really fully understand it, but I can see like it's important because you get to it right away, and it seems to be distinguishing your approach from what an ordinary approach might be.
So yeah, over the years, I've worked on a number of embedded systems. In the last 8 years, a lot of it's been position navigation and timing boxes for GPS satellites, for instance, or inertial guidance units. And the process was always hook up a JTAG, which is a way to debug the processor, and just try to build and test everything right on that hardware. Well, sometimes you don't have the hardware. You don't have a whole board yet because it can take a while to get it up or even get some of the hardware, some of the devices. Sometimes you'll have just a dev kit, meaning, a small separate board that you can talk to over, say, a UART or UDP or something. So trying to iteratively develop always on the hardware could take a long time. And you just really sometimes weren't really able to do it in any kind of a fast fashion. Most of your business logic for a device like this, you can just develop it right in Linux, just a regular operating system, right? Even a virtual machine if you wanted to. And then eventually it'll obviously it'll have to go on the hardware at some point, but by then you've unit tested all the different small pieces. So I'm building this thing up chapter by chapter and testing it right on Linux. Then most of it, yeah, you'll have your kind of your hardware layer with this actual hardware to talk to. And sometimes the dev kit is that, and it'll just work. But sometimes it's maybe something on an I2C device or through a driver, and you have to make a model of that on your Linux host, basically kind of mock it out. You know what I mean?
Mhm.
And develop, but you can develop all your system startup and pre-allocate your memory, which is very important in an embedded system to manage memory properly, manage your threads, and just build that whole, and then, so I'm building pipelines, data pipelines in here, and they'll work fine on the Linux host and on hardware. Now, there may be some translations to do later, like for you have to do STM32 or Integrity OS and things like that. But that's probably going to be some follow-up work. I'll show, okay, yeah, yes, I did this part for Linux and it won't work on your STM32. This is how you do it. And it's not rocket science, I don't think, does that make sense? I think.
Yeah, totally, totally. Yeah.
Yeah.
The last question I have is your book is currently marked at 80% complete. And I was just wondering if you have a plan for like when you're going to finish it. It's going to be done by the end of the month or the end of the year or.
I think in another probably five weeks or so, I'm well into chapter 11, which is showing how to take the inputs from the various sensors and synchronize them in time so that then you can make decisions about, you can predict, put up a weather prediction. I'm not sure what my output's going to be. That'll be chapter 12 when some of this I've kind of figured out as I've gone along, like, wait, what do I want this thing to do? Which is actually a great thing about Leanpub. It's like, if it was some other Manning or whatever, they'd want everything all laid out and perfect already, right? Before I even wrote it. This way I'm writing it, I have control.
Yeah, well, thank you for saying that. I mean, that is one of the reasons Leanpub exists the way it exists. I mean, obviously you can come to Leanpub with a completely finished book, or you can have I'm more of a complete plan kind of person myself.
Right.
But especially if you're working on like a certain kind of nonfiction book on a more or less kind of technical or theoretical subject, as you go along, you're like, oh, I need to change what I did back there. And I need to do this differently.
Yeah.
And Leanpub makes that really good and kind of exciting for the reader, because if the reader buys it early and they go along with you, they'll learn along with you and they'll be there for the moment when you're like, oh, we should have done it differently back in chapter 2.
Yes.
So we always love to see books like that. The book is Designing Deterministic Systems with Modern C++, host first development on Linux. Mark, thank you very much for taking the time today to talk to me and to talk to all of us. And thanks for your great book.
Thanks, Len.